This program is brought to you by the Center for a Sustainable Today. Our world is an amazing, complex living organism, and we coexist in a symbiotic relationship. With this great power comes a great responsibility, a responsibility to ensure the future by taking steps to be sustainable today. And now, here are the hosts of Sustainable Today.
Hi everyone, thanks for joining us once again. We're the show that helps you be more sustainable both at home and at work. I'm Darcy Hitchcock.
And I'm Marcia Willard, and today's program is about water, how we're going to ensure that we have enough of this precious resource as our population grows and as climate change takes its toll. And with us in the studio today is Lorna Stickle, who is a water program planning manager with the City of Portland's Water Bureau. So welcome, Lorna. Thank you for being here.
Thanks. Good to be here.
And we're looking forward to hearing what you have to say, but first, Darcy and I want to share a few things that we've come across in the news this month. And I'll kick off with an article that I saw in the Oregonian just the other day about race and environmentalism. You know, the environmental movement has a historical reputation for being a white, upper middle class
White folk thing, yes, exactly.
Yeah, and but we're starting to see a little bit more of that change and more diverse populations coming into it and getting exciting about it, primarily because we're starting to appreciate, or those populations are starting to appreciate that, you know, they're affected maybe even disproportionately by some of the things that are happening in the environment. And I think that as more opportunities for public engagement increase, that we'll see that diversity increase. And I was excited by yesterday's Focus the Nation program, which was January 31st. And many of you may have been aware of this large effort where it was a national teach-in, and it took place in all across the country on campuses and in churches and in businesses. And it focused on global warming and the impacts and what we can do about it. And here we had about 4,000 people show up at the University of Portland, including our governor and many of our political leaders, to talk about what actions could be taken.
The idea that you're going to let market forces determine whether in fact people are going to adapt to climate change is not the approach we have to take. We have to make some choices ourselves. The most important thing that the state of Oregon did was develop a renewable portfolio standard of 25% of this state's energy will come from renewable resources by 2025. What that did is it told investors all around the world that Oregon is serious about moving the state toward that objective.
We have this wonderfully weird ethos here. You know, this is part of our culture. So Oregon is leading the nation, and we have the opportunity, critically have the opportunity, to make the Northwest and specifically Oregon, you know, the epicenter of renewable, sustainable energy production and clean tech investing.
What do you think of this liquid gas proposal and why it's instantly obsolete?
The proposals for things like liquefied natural gas and other fossil fuel technologies, that is so yesterday. What we need to do is be looking forward and build our economy on new and sustainable forms of energy, which is good for the environment and will be great for our economy.
Very exciting, and we did see a good diverse population show up for that.
That is really exciting. I think we're doing, I think the environmental movement's gotten smarter about how to talk in ways that make sense to other people. I know that people of color oftentimes live in areas where they're more affected by air pollution and asthma, and so some of those health issues start to make sense to them. Related to that, I saw an interesting study that caught my eye. They were showing now that they think some of the things that we think of as normal aging may be related to lead exposure many, many years ago. That it made people's brains act like they were 5 years older than they were because of the lead that we might have gotten from lead-based paint or leaded gasoline and so forth. So, you know, it was 20 years ago that we cleaned up some of that, but we still may pay for it one of these days.
And there's still plenty of lead in our environment from industrial processes, and you'll love this one. I saw in a Parade article just the other day, in some study they tested lipstick And 33 of the brands that they studied had lead in them.
Great, right on your lips.
Yeah.
A neurotoxin,
Eating
easy to take it into your body. How great. That's incredible. How can that be?
Yeah, good question.
How can we let that happen?
And also related to that, and also I think has some bearing on today's topic, were some articles about pharmaceuticals. You know, pharmaceutical companies are taking heat for the fact that where drugs are showing up in our rivers. Cities have been encouraging people when they have leftover drugs or you know, don't finish a prescription to flush them down the toilet. And so they end up in the water system, and our water treatment systems are not designed to take those kinds of things out. So there you have it.
Yeah, that's amazing. So what do we do about that?
Well, in some communities, they're starting sort of take back for prescriptions. So if you have anything left over, you're supposed to take it to your pharmacy. Now, we don't have that here. They do in British Columbia, for example, and they're starting
Washington.
one in Washington, yeah. And so hopefully we can get something like that going here.
That would be great. I sure hope that happens. So related a little bit to this issue, since we're talking about water, I saw something fascinating in the Associated Press that in California, water is so tight that some farmers are stopping growing crops and instead selling their water.
Because it's more profitable to sell their water rights than to sell their
Right. Right.
Wow.
So where is this taking us? If we don't have water for food, what are we going to do?
Future.
And it's illegal for restaurants in Long Beach to serve customers a glass of water unless they ask for it. Guys, it really makes you have a sense of how constrained water supplies are starting to become.
Well, I know it's been bad in Southern California. I grew up down there. I still have family down there, and I'm hearing now about the Orange County is now reprocessing their wastewater, their sewage water, into drinking water.
Isn't that just going to drive everybody to drink bottled water? There's the yuck factor here.
You know, from what I understand, they're doing a good job of educating people, and you know, they've been aware of their water shortage for a long time, and so I think they're bringing people along with that. That would be a tough sell, though.
Well, the other thing I wanted to mention is that National Geographic did a whole spread this time on drying of the West because water is really a problem here. So this is maybe a good segue back into Lorna to involve you in the conversation. I know we can take water for granted here because we have a lot of rain in this part of the Pacific Northwest, but it is an issue. You're both with the Water Bureau and also the Water Providers Consortium. So tell us a little bit about those two things and what you do for them.
Great. The Regional Water Providers Consortium has been underway since 1997. And that's a group of about 23 water providers and our regional government metro that's been coordinating on water supply issues. Our primary programs today are pretty much focused on conservation, emergency preparedness, and coordinating ourselves together a little bit more than we have in the past. The Water Bureau provides staffing for that organization, and we were one of the leaders in getting that organization underway. So the Water Bureau provides water to both the City of Portland and to about 19 other wholesale entities within the region, and so we felt it was pretty important for us to all coordinate together as best we can. So
Well,
that's kind of what it's about.
So water is getting to be a big issue, water availability. We had that horrible drought in the southeast. I know there were communities in Georgia that just ran out of water. What is it what's the future like, and what are we going to be doing around assuring water availability?
Well, you mentioned earlier that we are really blessed here in the Portland region because we've got one of the second largest rivers in the whole country passing right through our urban area, and then the Willamette, which is also one of the larger rivers. But it doesn't mean that we shouldn't be looking to how are we going to meet future demands, because I'm sure, as you all know, the Portland region and many of the other regions in the Pacific Northwest and in other parts of the West have been growing almost exponentially.
Yeah.
We're very attractive environments. People come here, and of course they expect to have water supplies. And so one of our primary drivers is population growth itself. No matter how efficient you get, if you have more people coming in than you're saving, well, you still have to figure out how you're going to meet needs. Mm-hmm. And so there's two factors that I think are really critical here when we think about this issue, is that climate change itself is something that is going to affect, it already has begun to affect the availability of supplies, because as, again, you're probably aware, we have a lot of rain in the winter. We don't get very much in the summer.
Right,
and
we
so
may
that's
go 2 months with
exactly,
no rain at
several
all.
actually. And so, you know, as those summer months, that's when our peak demands are mainly driven by outdoor watering, and that's very typical of many places in the West. The other thing I would just throw out is that we tend to look back on about 60 years worth of records when we design new water supply systems, because that's how long those records are. But you don't have to look very far back into even the historical record, much less the prehistorical record, to know that, for instance, in 1840 to 1855, right here in the Northwest, we had that was our drought of record for the past 250 years. Well, we haven't seen anything like that. So apart from climate change, there's the whole factor that we've had a pretty stable set of years to base our water supplies on. And so taking a look at a greater amount of variability is probably what we need to be doing.
Well, but what I understand from climate change is that they expect the Northwest to be wetter. So doesn't that bode well for us, or how does that play into this?
Well, the whole issue of how to figure out what climate change will mean on the local level is sort of a new emerging area in water supply planning. And although some of the studies that have been done here in the Pacific Northwest would indicate that the winter months we may see more rainfall, we're also likely to see less snow. And less snowpack that accumulates in particularly the middle to lower elevations of the Cascades, for instance, so that we would wind up with drier summers and less stream flow during the summer months. So that's the issue.
Snowpack is like our reserve reservoir.
It's like a bank account for us. That's right.
I wonder if it might be interesting to talk about what the mechanics are about how climate change is affecting the hydrological cycle. How does that happen, and what are the dynamics? What's known, what's not known about that?
Well, there's a couple of things. I guess the global climate models that are run around obviously the world can be downscaled to the local level. It's another emerging field, but in general, I would say for pretty much the Western United States. The global climate models, the different ones that are run, pretty much tell us that temperature is going to increase. Now, there is a range of how much that would be, but nonetheless, the trend is upwards. When those same models are downscaled to take a look at what will happen to precipitation patterns, the range between the models is much, much greater. So it's a little less certain about how the precipitation patterns will happen, particularly some of those intense rainfall events that we often get in the winter, in the spring. Are we going to get more of those? Possibly so. The temperature signal, though, that does tell us something about the hydrology of our sources is that as temperatures rise, on average, you'll find that the basic snow level will rise also. And so as that happens, you'll find that in those lower elevations, instead of that accumulating as snow in the spring and winter, we'll get more of that happening as rainfall, which means it runs off faster.
And more floods.
Exactly, and more floods. And if you're not capturing that water in storage reservoirs, well, then it's lost to you later on in the summer. So. And then the contribution again to the spring and summer stream flows is less too. So.
And the incidence of larger, more severe storms also increases turbidity in our water. Is that going to be a problem too?
Yeah, that's something that many of us are looking at.
And what does that mean when we have turbidity in the water, and why is that a problem?
Well, for a filtered source, which say the Clackamas here in our region is filtered. Filtration plants generally can handle quite a high level of turbidity in a water source. It's the unfiltered sources in the West, for instance, that are likely to have the bigger problems. So that would include Bull Run, some of the sources in Seattle.
Source,
exactly. San Francisco, the Hetch Hetchy source is unfiltered. So on those sources, if you get more intense rainfall events that increase turbidity, well, then you're going to have periods of time when because if you're unfiltered, you're not treating for it. And so you'll have to turn to other sources.
Or it might mean adding expensive filtration systems.
Yes, that could be an impact, right?
So we've talked regionally a lot. Do you have much information about globally what the picture's like, and are there certain hot spots that we should be worried about worldwide?
Well, yeah, and I don't want to portray myself as being necessarily an expert about global patterns, but some of the things that are being talked about, for instance, Australia has been suffering through multi-years of drought, and they are likely to see more of that. Intense events in Europe, for instance, like that heat wave that they had a few years ago, right. And then some of the more intense patterns. There was a hurricane in Brazil a couple of years ago, unheard of. Hurricanes normally don't form in the southern hemisphere. So those sort of off-the-chart weather events, more drying generally in some of the tropic areas, the drying out of the Amazon. Rainforest would be a substantially important event because that affects world patterns. The melting of the ice sheets in Antarctica and in Greenland are also another issue that has a lot of scientists concerned.
So I think we have a spotlight.
This month we're going into the Portland community to focus on a neighborhood that's done something about not only conserving water but making it kind of fun in the process. The members of the community that created this special place are learning about water purification and wildlife and conservation, all while enjoying a lovely garden. The students and members of the community built this 6 years ago, and today the legacy lives on. And so we go now to Gordon Westfall to take a look at this very special place.
So we're here with Dan Evans here at the Da Vinci School of Arts in Northeast Portland, and we're at the water garden, and it's raining. How appropriate.
Yes, and we call it water garden because what we're doing here is we've taken a piece of land that was not usable. It was an abandoned tennis court, and it was just concrete. And we've removed the concrete, and the students designed a garden space that would accept the rainwater from these 3 portable classrooms and the parking lot. Now normally this rainwater would go into the sewer system, and we know living in Portland that we have these combined sewers, and the sewer system here just doesn't need any more rainwater. Certainly doesn't need to treat it because it's clean. When we approached the Bureau of Environmental Services 4 years ago, we had an idea that we wanted to build a garden here and take the rainwater off the roofs and off the parking lot. And so they were interested, and so we began planning. It took us a year to plan it, took us a year to build it, and this is the 4th year since we finished the building of the water garden. These students are volunteers to come out and tell you a little bit about the water garden. Today they are performing, because this is an arts magnet, they're performing in a dance performance. These are dancers and students at the Da Vinci School. And they are users of the garden. They help maintain the garden, and they can tell you a little bit about what we've done out in the garden this year, because we used the garden when we studied animals this year in life science.
My name is Lily Wood, and I'm an 8th grader at Da Vinci Arts Middle School.
Hi, I'm Georgia Wiley, and I'm also an 8th grader here.
These 2 tanks here they store rainwater, like it is right now raining. The water comes off the roofs and goes into these 2 tanks, which then comes out of this black pipe and that white dragon and fills up the pond. And when the pond overflows, the water pours down into a little river-type stream bank over there, and you have a little river. And that river goes into, on the far side, some wetlands, and then you can look at little other animals and life in there. So you see the waterfall with the 3 tiers. What happens here is the water from the pond is recirculated through those 3 shelves, and when it goes through the shelves, it's cleaned, and it's called a flow form. And it cleans through those shelves and then comes back into the pond. So it's a whole recirculating regeneration process with the water.
My name is Bridget Emard. I'm an 8th grader at Da Vinci Arts Middle School. And right now, these students are fishing for insects in this pond. And some of the insects you will find in here will be water scorpions, water boatmen, and sometimes dragonfly nymphs. There have been several fish. We had one large fish named Moby, but he was eaten by a great blue heron a while back.
My name is Lauren Hestan, and I'm a 6th grader here at Da Vinci Arts Middle School. And this is our wonderful stream. This stream exhibits 750,000 gallons of overflowed rainwater from our pond into a second pond, and which normally would go into the sewer system, but goes back into the earth to be used for our plant life at the Da Vinci Water Garden.
Hi, I'm Sara from Da Vinci, and I'm an 8th grader. And right next to me is the bioswale where the water from the parking lot flows down into and meets up with the stream. And what happens is that when it rains, the water from the parking lot, flows off the curb and then down here where this native plant life is, and all these plants are native right here. And what happens is that when the water flows down here, these plants, the plants and the bioswale cleans out whatever oil or something might be in the water, because of course the cars might leave some traces of gasoline in the water. And the reason why the water doesn't just go straight to the pond is that the oil or whatever that might be in the water might hurt the animals. So it just flows down here and then meets up with the stream and then goes down to the wetlands.
Now what we're looking into here is a living machine. And this living machine takes the liquid waste from our cafeteria and converts it into gray water using organisms like the native plants here in the garden and fish and snails. The process begins in the back here where we deposit the milk and juice. It overflows into the first tank, which has algae and duckweed, and they're attached to screening. The water slowly permeates into 2 more tanks that have floating plants, no soil, just the plants floating in the water, and the roots are absorbing the nutrients. This here that has all of this stubble sticking out, this tank is a wetland tank. It's filled with gravel up to this point, and all of these plants are native plants. Native wapato, which the Native Americans used to eat, like a potato, along with hedges and sedges. The water then transfers into the final tank, which is filled with fish and snails. And then when our water level gets high enough, I open up this valve at the bottom and I insert one of these pipes into this valve, and then we release the water out to the stream. This is a model system. This is only 300 gallons, but there is an actual system, a living machine, down in Astoria. It's been in existence for about 3 years, and this system is at the Marine Center, the MERTS Center, and it takes care of all the waste, not just the liquid waste, but the solid waste and everything that they generate there at that campus site. It's pretty interesting. So when we release water from our living machine and it joins this bioswale, it enters this stream and rolls under that bridge and goes out to the wetland. And that's where we're going to go next. Well, I'm walking down into our wetland and I'm coming up on the stream where the water from the parking lot and the water from the pond all drains down into this lowland area. The water drains to this point here and then starts to permeate into the soil. It gets to a depth of about a foot or so, maybe up to my knee. And all of these plants are designed to drink up as much water as possible. These are wetland plants, all native to Oregon. And the other interesting thing is they like to be dried out in the summertime. So we don't have to worry about this area. This area is self-sustaining. This is the end result. All the rainwater comes down here from the parking lot, the roofs, and through the pond, and goes back to the earth instead of the sewer. So we believe that this garden has the capacity to hold much more water than we already take in. We take in about 750,000 gallons of rainwater annually, and I believe that this garden space could probably take on twice that much. These plants are now, their roots are established deep into the soil, so they've opened up the soil so that the rainwater can now really go down deep into the earth and return to the water tables where it belongs. So here we are in a garden. And this garden is very low tech, and it represents nature and sustainability. And suddenly you see something that looks like it landed from outer space. This is our 1 kilowatt solar panel that produces electricity to offset the electricity that we use in the running of the pumps, both in the living machine and in the pond itself. And this is very, very cool. This whole contraption moves as it gets heated up right here on these pontoons. It moves and tracks the sun so that it gets maximum exposure to sunlight. And then the electricity from here is sent back into the building, and it's kept in order on a computerized basis so that we can keep track of how much electricity we're actually creating versus how much electricity we're actually using. This thing can create anywhere from 350 to 750 kilowatts per hour on a good day. And the use that we're using right now is pretty minimal because our pumping water is pretty small. But we envision in the future of having concerts out here and having amplification going on with our music. And so this solar panel will help offset some of the cost in having community-funded projects out here in the garden and in the garden spaces. Some people might ask, how do you build a garden like this? And to be honest with you, the way you build a garden like this is you enroll people. This garden was not built solely on money. In fact, the budget for this garden was just a fraction of what it cost to build spaces like this. We were able to build this garden with seed money from the Bureau of Environmental Services at about $30,000. We ended up getting about $40,000 in kind. That meant professionals donated their time to help us build it. But the basic building of this garden was done by the hands of people in the community. The children and their parents came out over a year and actually dug in and built it. Now, that's a great savings because right now we're building gardens and water sustainability at a cost almost 10 times or 20 times that amount. So I really believe that if we set our goals to involve our community and involve our children in projects like this, that these gardens will last. They will be here for the future because if the kids and the community build these gardens, they're going to want to come back and tend to these gardens. But if they're simply built by other people as public works services, nobody really has a connection to them. So it's the enrollment that puts a garden like this together.
So Lorna, we're known for our rain here, and we've got some great water supplies, but tell us a little bit about the main water supplies for our region here, where they are. I think the Bull Run is really special, I've heard, but I don't know a lot about it. So tell us a little bit about what we have that stores water for us now to pull from.
Well, I think that generally, certainly the Bull Run is one of the more well-known water sources when people think about the Portland area. I think what a lot of people don't realize is that a fairly significant portion of our region is served by other water supplies, and we are blessed, as I said earlier, by having a fair amount of water that we can draw from. So I brought a map, and on that map it indicates where the different water supplies are in our region. Certainly we have the Bull Run watershed, which is on the slopes of the Cascade. That water system is backed up by a large groundwater system that is located between the Portland Airport and Blue Lake Park. So in conjunction, those two sources fulfill the needs of a fair portion of the region. Probably about 60% of the region is supplied by those two sources. But in addition to that, there are 4 intakes on the Clackamas River, all down in the lower couple of miles before it enters the Willamette. There's also a fairly significant system on the west side of our region that serves the Washington County area, that's made up of 2 reservoir systems. One is on a branch of the Trask River. Another one is on a branch of the Tualatin River, Hag Lake. So that system together serves a fair portion of Washington County. Recently, just within the last 3 or 4 years, Wilsonville has brought on the Willamette as a treated water source. And then there are
that was quite controversial,
yes,
as I recall.
Yes, it was. But that plant has
the
been
cleanest river in the world.
Well, true.
But what I like about that is it forces us to think about how clean the river is. I mean, I can't think of a better way to get people to think about their river than to say, drink it.
That's exactly right. It is true. That plant has been performing extremely well. The quality of that water is very high.
So the big question is it enough? So you started earlier in the program talking about we're a growing region, our sources are going to be not in question, but they're going to be affected by global warming. So are they going to be enough to supply the growing demand, or are we going to have to do more conservation, more reservoirs, more dams? What's the outlook look like?
I think that, when you have Metro, our regional government, saying that within the next 30 years we're anticipating 715,000 additional people, that's a lot of additional people.
Wow, that's a lot of toilets.
Yeah, that's true. Low flush, hopefully, but yeah. Growth probably is the primary driver of how much additional water supplies we will need. Some of the supplies that I mentioned earlier do have some added capacity, or there are additional water rights that are available so that they could be expanded. I don't think there's really any question, though, that we will be needing to look to some additional supplies as well as using water more efficiently.
You're going to build a dam somewhere? Are you going to build a new reservoir somewhere? Are you going to dig a big hole in the ground and fill it up with water in the winter? How are you going to do this?
Well, the Bull Run system, for instance, has some added capacity, particularly because we do have the large groundwater system that can augment those supplies in the summer.
Tell me what that means, though.
So there's a place to store it when there's stuff in it?
No, actually what it means is that in the summertime you would be relying on the surface water storage in Bull Run, but you would augment that through pumping out of wells along the Columbia South Shore.
Okay.
And so together we mix that water.
How is our water used overall in terms of the various sectors? I've heard that agriculture is a big user of water regionally and nationally. So who's using the most of it, and what do they need to be doing to conserve, if that's part of the puzzle here?
Well, certainly in some parts of the West, agricultural water use overall, when you're talking about how much water is diverted either out of the groundwater systems or out of the surface water systems, agriculture is by far the largest diverter of water. It's probably over 80% in terms of the actual diverted water. So municipal supplies are a much smaller part of the picture. Agriculture, though, is being looked to as one of the places where future water supplies are going to have to come from. And to some extent, some of that involves purchasing water rights from farmers who then would either be getting out of production or they would go to dryland farming. But there are other circumstances where you can look at win-win situations where the municipalities who want that water will help the farmers fund conservation projects. And those can include things like lining canals so that less water is lost to leakage, or it can involve on-farm water irrigation improvements. I don't know how many of you have been through Eastern Oregon and seen those giant water pivots, right? And if they are very large cannon users that are spraying from the top of the pivot out and over, some of those systems, well, they can
in a
be
dry climate.
Well, I'd say a lot of the farmers have learned to become much more efficient because as the price of power has gone up, the price of pumping, most of that's groundwater, and pumping that out of the ground is very expensive, plus a lot of those sources have been declining. And so I don't know if you notice it, but a number of those that you go through the state now, you'll notice they have lines that drape down from those pivot lines, and they'll get much closer to the ground and they'll have a finer spray. Well, that's a way that they have been able to significantly improve how they apply water. So, I think that agriculture and municipalities are forming alliances Other ways that they're looking at is the establishment of water banks, where water, when it's in good supply, can be purchased so that it could be used by municipalities in the summer during years when supplies are in a little bit shorter demand. So I think there's a number of things that are happening.
Those are interesting strategies, and it makes me think that those are very positive approaches to this, what is a very controversial issue, I know, in our region about water rights. And so it also speaks to the need for policy changes because, you know, currently there's that use it or lose it kind of mentality. If I own the rights to something, I better use it up. So any other policy kinds of things that are that you see coming on the horizon? Or
Yeah, I think that a lot of Western states are having to look at their water rights structure. The prior appropriation system was not designed to be flexible. The one area that I think I should point out, though, is that municipalities are the one class of entities that are able to hold water rights for long periods of time without using them. So the use it or lose it does not necessarily apply to municipalities. For agriculture, on the other hand, it generally does apply. And so some of the things that are being looked at are leases of water rights. In Oregon, a couple sessions ago, they passed something called split season leasing, which is where agricultural folks can split out how they're able to use their water so that they use it more efficiently at the times when they do, but then they're able to, say, lease some of that excess to, say, fulfill in-stream water needs.
Interesting strategies.
It's such a complicated area with all the laws and the you know, the Western water rights are such an emotional thing. It's going to be a very interesting time to see how we solve all of this. So we've got a business spotlight for you. Stormwater runoff and pollution management are two of the biggest contributors to the degradation of our streams and lakes. But there are ways of limiting or even eliminating many of these problems. Our business spotlight focuses on landscapers who have found ingenious ways of handling runoff and offering pollution-free lawn and garden maintenance services. Katie Wood takes us to a new development in Salem with a difference.
Hi, I'm Katie Wood, and today we're here at the Fairview Mental Hospital, which is currently under reconstruction into a residential and commercial area called Kringle Creek Community. Today we're talking with Dean DeSantis, who is owner and president of DeSantis Landscaping. Hi, Dean. How are you doing today?
Great, thanks.
Wonderful. So what is so special about this commercial project that you have going on here?
Well, it's primarily a residential project. We've got 140 home lots that are being built here, and I think it's probably one of the greenest projects, not only in the state, but probably in the country. It's 32 acres, and they've really focused on the natural beauty of the site and keeping it as pristine and green as possible.
And another big part is water conservation, right? We're thinking about how to use water and reuse water and
definitely.
Like that.
That's been something. There's actually no stormwater system in the entire community at all. There's all sorts of studies that have been done to show, you know, how much water the soil can take.
Well, let's go check some of these areas out.
All right.
Sounds great. So here we are, one of your rain gardens. What is actually the function of a rain garden here?
Well, the rain gardens are part of the stormwater management system that we've got going here at Kringle Creek. At every intersection, there are 8 of these, 2 at each corner, and they handle any of the runoff that isn't absorbed through the porous asphalt pavement. And what we've got, the plants in here are your typical native wetland plants that you'd see in any boggy kind of area around Oregon. They're rushes and sedges that are in the rain garden.
And what is this soil that you have them planted here? Is this a special mixture or
actually it's the native topsoil. We've got a stockpile of the native topsoil that's been excavated out, and we've stockpiled that, and we're putting that now back into this rain garden. There's the way it's built is there's about 12 to 18 inches of drain rock, and then we've got another 12 to 18 inches of soil on top of that. So it's got great drainage. And can handle a lot of water. In a year or so, this thing is going to be completely full of grasses throughout the entire swale here. It's really just a small swale.
Okay. So earlier you mentioned the roads. There's something special about these roads. It's not your typical pavement. What did you call it before?
It's porous asphalt, and yeah, the water when it hits the pavement, typically, and this is one of the biggest problems in an urban area, residential street, is that you've got so much runoff of the asphalt. And with porous asphalt, the water just percolates right down through the asphalt and into the soil. So let me show you a little bit here. Yeah, a little demonstration here.
Wow.
There it goes. You know, with the creek over here, we don't have water, you know, being diverted and run into a creek or waterways, which is fairly typical in other developments. So this, in combination with the rain gardens, we're able to handle all the natural rainwater right here on the street.
Puddling and
exactly
small lakes forming in people's yards.
Right. Yeah. Typically, you'd have like a street sweeper. Well, here they'll have a street vacuum, because if you get too much dirt and soil into the pavement, it's going to clog up the street, and that's going to not allow the drainage. So they'll be sucking the dirt out of this pavement.
Okay.
Yeah.
So this is Kringle Creek development. Obviously there's a creek that runs through it, and you're now currently planting plants along this. Why exactly are you doing that? What is its purpose?
This is the riparian area that we're planting right here. And as you can kind of see, it just used to be just, you know, Himalayan blackberries that are growing up here. And so we've come in and we've cut down those invasive plants, and we're planting with a native planting. So we've got things like red alder and western red cedar and some willows that are in here. And those are the plants that are accustomed to the amount of rainfall we get here, and just the climate that we've got in the Willamette Valley. So this will grow up and be a pretty solid, almost a hedgerow along this here. It'll be a great habitat for birds and for small mammals. It'll be something where the water will be able to, it'll filter through that riparian area before it gets to the creek. So there's a lot of benefits of it.
And what about those invasive plants? Are those going to continue to be a problem?
Yeah, this blackberry right here is going to be right back in the springtime, and we of course didn't want to spray right near the creek here. So it's going to be a maintenance issue, and it always is with a riparian area like that. So we'll be in here clearing that out once the blackberries grow back up, and eventually the natives will be they'll be stronger and established, and we'll be able to control the invasives just with the plantings there.
And over here on the left, we have another little trench going on. What's happening over here on this side of the road?
This is actually an overflow that when the creek rises very quickly when you get a heavy rainfall. And so the pathway here is low enough that the creek flows over into this overflow. And so we're doing the same kind of planting along here, the same native plantings. And part of it is, you know, the benefits of the riparian area that I just mentioned, but also just from a safety perspective, you've got a walking path that's being put in here. And, you know, if kids are riding their bikes or something, that's a pretty steep bank, so we want to create a buffer there so that kids don't fall and slip down into the swale.
So all over the site, you have these tubes popping up, and this is the end of the irrigation, right? Or
yeah, this is actually where we'll connect the head, the sprinkler head, onto this what we call a funny pipe. And that pipe can move around, so we can place our head right where we want it. This whole system is really pretty unique in that it's an irrigation, and also it's a geothermal heating and cooling system. It's kind of a hybrid. In the background here, you can see that the smokestack back there, right at the base of that is a well that pumps about 250 gallons a minute. And so what we've designed here is a system that pumps out of the well, goes into the homes and the commercial buildings to be used for heating and cooling. It goes through a geothermal heat pump. It's not hot water that we're pulling up out of the ground, but the heat pump actually takes the energy from the water and creates hot air or cold air for the homes and commercial buildings. And then when it does its job there, it exits the home or building and goes into our irrigation system, which waters the plants and the turf and everything. And what's not used for the irrigation goes back into an injection well and back into the aquifer and kind of closes the loop. There's kind of a double use of the water. Another benefit, you know, we've minimized the use of PVC. We've basically used 50% of the PVC that we would normally use with two standalone systems. So we've saved a lot of, as well as a huge energy savings by, you know, combining the two systems.
So here we are at one of your mature landscapes that you've done. This is Kringle Creek. Explain to us, how How do you use this creek in the landscape to really help the plants grow, and what happens when the creek overflows and things like that?
Great, yeah. Really, the creek is, we view it as a an awesome feature in the landscape, and but it does, yeah. When it rains real heavily, the creek rises up very quickly, and so we've got areas over here that used to just flood out over the turf and flood plants, and we've created a dry creek bed so to handle that overflow and direct more of the water back into the creek bed itself.
From the plants, the fertilization up on the yard and in the lawn, does that affect the creek at all, or pollute it or anything like that? Or
Very much so. That's really one of the biggest problems that we've got in the Willamette Valley. In the Willamette River, a lot of is the runoff from golf courses and farms and homes with the fertilizers and pesticides running off into our waterways. And so on this property, we haven't used any pesticides or synthetic fertilizers for over 2 years. And as you look around, it's pretty amazing, because most people think of it as like, oh my gosh, if I don't use Roundup to kill those weeds, it's gonna be a weed patch.
in the fertilization, you also have something called compost tea. I understand. What
Right,
exactly
yeah.
is compost tea? How does that help?
Compost tea is kind of a blend. It's a brew, literally, of lots of the good biological critters that are in the soil. One of the keys to good landscaping and good sustainable landscaping is to have good soil conditioning. If you've got a really packed, compacted soil, you're not going to get good drainage. Your water is going to be puddle and run off. If you've got a nice, a good soil that's got good biology, those little critters are creating little tunnels through there and creating better drainage.
How do you find out what type of soil you have or what type of compost tea you need? Is there someone you can talk to, or how does that work?
Yeah, there are soil labs, and that we use soil labs ourselves. We take a soil sample, and they give you a little bag that you can send to the lab, and so they come back with a soil analysis that tells you, the different elements that you've got in your soil, which would then tell you, what additives you might need into your soil. And when we actually brew compost tea, we take that soil sample and we can brew a tea to exactly match what the soil needs, so we can bring it back to a good balance. Essentially, it's a big tea bag. It's a big cylinder that goes into a 500-gallon brewer, and it's aerated, so the water just goes around, and it's basically like tea. It's steeping, and so all the good stuff is coming out of that compost and creates this really powerful, good biological potion, essentially. Yeah.
Well, how cool.
Yeah.
So a new term that has been thrown out there in landscaping business is xeriscaping. What exactly is that?
Yeah, great question. Xeriscaping is, a lot of people, when they think about xeriscaping, they think of cactuses and rock gardens and things like that. And that's xeriscaping, but it really fits more for the Southwest. Here in the Pacific Northwest, we can do xeriscaping, and really xeriscaping is about minimizing inputs. Water, fertilizers. Like if we look along the creek here, we can see some of the native plantings along here, the dogwoods and the willows, but mixed in with some ornamentals to give some color. Because xeriscaping here in the Northwest can still be green and lush, but you're not going to get a whole lot of color with the blooms and things like that. So what we've done here is mix in some of those ornamentals to give us the bloom.
Do the ornamental plants attract more pests than the native plants, or how does that work?
That's a great point. Yes, the native plants are much more pest resistant. Again, they're native to this area and they're accustomed to the climate and conditions. But our native plants can really they can handle more of those wet conditions like we have here in the Northwest. Just beyond those dogwood, sort of a reedy rush plant, and that does real well along stream beds and in wetland areas. So plantings like that, they're native, they like the wet conditions, and they don't need any fertilizers. It's the right plant for the right place. So you mentioned microclimates. If we've got a really hot spot in a landscape that's full sun, well, that's gonna necessitate different types of plants than if you've got a real shady area that's in maybe a forest. You've got to, you really need to look at that, and good design. It all starts with good design. You need to be looking at, your microclimates, the soil type. All of that goes into a good xeriscape plan.
Another important part of yard management is, of course, watering, but we're talking about water conservation. So today I'm speaking with Brent Stevenson from DeSantis Landscapes. And Brent, you are the Irrigation Division Manager at DeSantis Landscapes, correct?
Yes, correct.
All right, and in irrigating a yard, how do you make it efficient so you're not wasting a bunch of water? What are things that you want to look for and think about?
Well, some of the most important things are, first off, is understanding the soil characteristics of where you're applying the water, and then looking at the ultimate goal of the landscapes. For example, on this site, we're using highly efficient drip irrigation. We're irrigating each individual plant instead of a spray head or some other manner. That way you don't get water that's over applied and running off, and you see it many areas where water's running over the sidewalk and down the street.
How do you know how much water is needed?
This site is a little more high-tech. We actually have an on-site weather station that monitors wind and temperature and humidity, and by that we can calculate the amount of use that water or the plants we require. From the field here, it radio transmits back to a main point at the house, and then it's connected to a phone line that's then tied to our office, and we can turn the system at any point on and off from our office. If the system doesn't turn on during a rainy period, also in the early spring, you can monitor and reduce the amount that you apply instead of just turning it on and having it apply the full summertime rate.
And that concludes our little tour of the microclimates and yard management with water conservation. Just wanted to thank Dean, Brent, thank you so much for being with us today.
It was our pleasure.
Had a great time, thank you.
Thanks.
And I'm Katie Wood, bringing you the tools today to make you more sustainable.
So now we turn to our call to action, the opportunity to help you understand what you can do to help our water supplies. And we have this broken out into 3 sections: outdoor, home use, and business use, because both home and business have outdoors. So outdoors, one of the biggest things you can do is create healthy soils, because they'll hold the water when it rains. And if you replace turf grass with other things such as native plants that don't need a lot of water, also water to the weather. If it's been raining, turn off your system or buy a weather-controlled system that won't irrigate when it doesn't need it. And tune up your irrigation system, look for leaks and such. And then in your house, be sure to install water-efficient fixtures throughout your home. That may be, the toilet alone can use 25 or 26% of your indoor water, an amazing amount. And be sure to use water wisely. Think about it. You can get a shower timer probably from your local utility. You can I capture water from my shower when I'm waiting for the hot water to come in. I capture that in a bucket and use it for plants. Use full washer loads, that sort of thing can make a big difference. So Marcia, what about you? What about business?
Well, business is obviously, if you are in an industrial process, is where a lot of the water goes for most businesses that are in manufacturing, and we talked about agriculture. But those water uses that almost all businesses share are usually get sucked up mostly by restrooms, heating and cooling, and landscaping, as Darcy mentioned, in the outdoor area. So thinking about heating and cooling and restrooms in your businesses, think about replacing those inefficient fixtures in your bathrooms, the toilets and the faucets, with more efficient low-flow kinds of fixtures. And people don't see this because it's usually hidden in a closet, but your heating and cooling system, many systems require single pass-through water for cooling. So to the extent that you can replace water-cooled systems with air-cooled systems, you could save a lot of water that way. And also the water department recommends graphing and analyzing your water use to see where it's going and how much you're using. That's what's going to alert you to potential leaks and things like that that might just be wasting water needlessly.
So Lorna, if people wanted to learn a lot more about climate change and water supplies, what are some of your favorite resources that you'd point them toward?
I think there's some really great ones out there, Darcy. If you want to know about climate change impacts, The Climate Change Impacts Group at the University of Washington has a fabulous set of information for folks. If you want to know about water generally in the state of Oregon, the Oregon Water Resources Department also has a very good webpage, and I highly recommend that. And then lastly, if you're from this Portland region, the Regional Water Providers Consortium has a really good webpage where you can get a lot of good information about what you can do to save water in your home.
Great.
So what about people who are interested about global issues around water? Because there's a billion people who don't have access to clean drinking water. Are there organizations that they could go to for information about that?
Yeah, there's information certainly on the Water for People website, which is a very good group that is helping people understand and to get a better situation for water in other parts of the world where it's very difficult to get a good water supply and a clean water supply. And then the World Health Organization, which also has a website.
That's great. So sort of the main message here is conservation, right?
Conserve.
Right? That's about all of us are able to do.
Yeah.
We can't make it rain more or less, and we can't change when that happens, but we know that there are pressures coming. We've had an easy time of it, haven't we, for a number of years, but between climate change and the growth that's coming, we're all going to have to scale back.
I know I've cut my water use probably by more than half in the last 5 years, just by being aware of some of these opportunities. And that was literally money down the drain that I was spending.
That's right.
So
I agree.
It behooves me, and it seems to contribute to our economy and our environment as well.
And I think it helps that some of the fixtures that we have in our home now are available that use a whole lot less water.
Yes, and they've finally come up with fixtures that actually work. I remember my mother complaining about the first low-flow toilets, and it wasn't 5 times. Yeah, right. So it didn't really save much water there. But anyway, well, Lorna, thank you so much for taking time out of your busy schedule to come on the show with us today. It's been very interesting.
Very informative. Thank you very much.
Thank you.
And we'd like to invite viewers to join us next month. We'll have a very interesting topic. It will be clean technology, and we have with us Ron Pernick, who wrote the book The Clean Tech Revolution, talking about the new industries that are emerging from the green collar workforce and the green collar industries.
So remember, it starts with you. I'm Darcy Hitchcock.
And I'm Marcia Willard, providing you the tools that you need to be sustainable today.
There's a big, beautiful planet in the sky. It's my home, it's where I live. You and many others live here too. The earth is our home, it's where we live. We can feel the power of the noonday sun, a blazing ball of fire up above, shining light and warmth enough for everyone, a gift to every nation from a star. There's a big, beautiful planet in the sky. It's my home, it's where I live. You and many others live here too. The earth is our home.